What's poppin', dogs? Mr. Allen here with some solving of systems of equations using elimination and substitution method. But, spoiler alert, in this video we're going to see examples where there's infinitely many solutions and no solutions and how they are somewhat similar but a little bit different pending the method that you're using. So, let's get after it, elimination method, and look at this. Already set up to eliminate both variables. Interesting here, right? The x's are going to cancel, they're gone. The y's are going to cancel, they're gone. And we're left with 0 equals 18. Well, that ain't true. So that's no solution. All right. No solution there. Not a true statement. No solution is my answer. Let's see what happens on this one here. I don't know. All right. First one, I'm going to multiply this guy by a -2, would then get it to -4, and allow me to cancel, right? So if I multiply the whole bottom equation there, the top one's going to stay the same, 4x plus 2y equals 10, and then I'd have -4x minus 2y equals -10. Now that's not technically proper math notation here, where I just throw the -2 and I multiply through. People are like, well, you got to show it on both sides. Whatever, bro. All right? I'm going to do it how I want to do it, okay? I'm multiplying by -2 through everything. I deal with systems a little differently than I would necessarily in normal algebra land. All right? Okay, cool. If you want to bring it up, throw it in the comments and be like, bro, that's trash. And be like, okay, cool. Now my x's are going to cancel here, right? My x's are gone, 0. Oh my goodness, my y's are gone too. So that's 0. 10, -10, that's 0. Oh, that's a true statement, isn't it? So this would be infinitely, and let me show you how I like to write it, infinitely many solutions. Now, you might want to run that one by your teacher before you try to do that, okay? It's like street talk right there, okay? They might not accept it, but I like it. It's less writing, and it allows me to practice my infinity signs, right? And if you don't know how to spell infinitely many, you're all set. I do know how to spell, all right? Infinitely many solutions. And now I'm out of room. Okay, so either way you want to do it, it's up to you guys. And if your teacher's cool with that, I mean, I think it's cool. So you should probably do it. All right, anyways. Run it by them, though. I don't want you to get it wrong, okay? Substitution method. Luckily, this one's already set up with y equals, right? Or if it was x equals, that would work too. But we got it as y equals. So I'm going to substitute this in here for that y. So let's see what we got. We got 6x minus 2, and then parentheses, we got 3x plus 5 in for y equals 14. Cool? So I'm just taking this guy here, and I'm substituting it in for this guy right here. All right? All right. So now I'm going to distribute this -2 to both parts here. So I got 6x minus 10 equals 14. Well, these x's are gone, and I'm left with the statement of -10 equals 14, which is not true. Just like this last one here, or the previous couple back. No solution. So basically what we're getting at here is if I'm left with a non-true statement and all my variables have canceled, it's a no solution. If I'm left with a true statement, oftentimes 0 equals 0, then it's infinitely many solutions. Not all real numbers, okay? Not all real numbers. I couldn't pick any x and any y and throw it in there and have it work, okay? It's infinitely many solutions, okay? There's an infinite number of combinations, essentially, of x and y that'll make this thing work, okay? Cool. And it's weird to think about how all real numbers is not the same, okay? But it's not. Be careful with systems and using that, all right? Infinitely many solutions is the way to go, okay? Next one. Let's see here. I've got my y again, so we'll just go ahead and take this, plug it into that guy up there. So I'm going to have 2x plus 4, parentheses, -1/2 x plus 3, and then that equals 12, right? So I just took this equation here, I plugged it in for that y. We got the 4 that we got to distribute now, and I've got 2x, that's going to be 4 and -1/2 is -2x, plus 12 equals 12. Well, my x's cancel, and I'm left with 12 equals 12. That's a true statement, right? So this would be infinitely many. You know what? I'm going with my infinitely many solutions. Why I decided to circle that one, but none of the others, I don't know. Now I feel like I need to go back and circle them all. All right? But there we go. So a lot of the elimination method, you're generally going to see where you end up with like 0, 0 because everything just gets eliminated, right? But in substitution, we're often left with 12 equals 12 or a 5 equals 5. It could be 0 equals 0, but a lot of times you might be left with like something like that where you actually have some numerical values there, not just 0 equals 0. All right, there we go, guys. Those are the special cases of solving systems of equations where you have infinitely many, right? Not all real numbers, infinitely many solutions and no solution situations. Hopefully that helps. If so, you liked it, like it for realsies, hit that thumbs up, right? Subscribe, all the YouTube dope things, and have a great day.